At 3:47 in the morning on February 9th, 1948, a switcher locomotive at Proviso Yard in Melrose Park, Illinois, pushed a cut of 18 freight cars over the hump. The cars rolled free one by one. A boxcar loaded with canned goods, a flat car carrying steel coil, a tank car out of Joliet. Each one gathering speed in the February cold, each one sent rolling by gravity alone into the classification bowl below. The yard stretched for miles in every direction. 300 arc lamps burned overhead. The ground vibrated with the sound of steel wheels on steel rail. Proviso Yard, operated by the Chicago and Northwestern Railway, had been the largest hump classification yard in the world when it opened in 1929. By 1948, it was processing thousands of cars every day on its dozens of classification tracks. 40 miles west, at Clearing Yard in Bedford Park, the Belt Railway of Chicago was doing the same. Sorting cars for 6 different railroads simultaneously, sending freight east, west, north, and south from a facility that stretched 5.5 miles across the Illinois prairie. This was Chicago, the rail hub at the center of the continent, the point through which a quarter of all American freight traffic moved. The system was extraordinary. Most people never knew it existed. The freight yards of Chicago were not a single place. They were a geography. Dozens of facilities spread across hundreds of square miles, each one a node in a network that had no parallel anywhere on Earth. Before we go further, if this kind of story matters to you, consider subscribing to the channel. Every video here is built around the systems that actually hold this country together. The power lines, the rail corridors, the infrastructure that most people never think about until it stops working. If that's the kind of documentation you want to keep watching, the subscribe button is how you tell us. And we want to hear from you. Did you work on a transmission line, a railway, a pipeline, a hydroelectric facility? Did a parent or grandparent spend their career maintaining infrastructure like this, keeping the lights on, keeping the freight moving? Leave it in the comments. These stories belong in this record. Now, back to the system. Chicago became the center of North American rail freight for reasons that had nothing to do with planning and everything to do with geography. One of the continent's major rail routes converged on the southern tip of Lake Michigan. There was no way around it. Any train moving between the eastern seaboard and the American West had to pass through or around Chicago. Any car moving between the industrial Midwest and Gulf Coast ports did the same. The city sat at the intersection of every corridor that mattered. And by the 1930s, more than 40 railroads operated within its terminal limits. Freight did not flow smoothly through this intersection. It arrived on one railroad's tracks and needed to be delivered to another's. A boxcar originating in St. Louis on the Illinois Central might carry goods destined for a shipper served only by the Chicago and Northwestern. To complete that journey, the car had to be physically transferred, moved across the city, assorted with other cars heading the same direction, and assembled into a new train. The Belt Railway of Chicago existed to manage exactly this problem. Incorporated in 1882 and operated by its owner railroads collectively, the Belt's 28 miles of main line threaded through the city's freight districts, connecting every major carrier. Its Clearing Yard in Bedford Park served as the primary interchange facility, the room where the logic of continental rail freight was sorted out, track by track. The scale was staggering. In a single 24-hour period, Clearing classified 40 to 50 miles of train consists every single day. The hump was not a dramatic feature. Seen from the outside, it was barely visible. A gentle rise in the track of perhaps 4 to 6 feet, engineered with precision so that a freight car rolling free from its crest would travel exactly far enough into the classification bowl to couple onto waiting cars without crashing into them. The geometry was the system. A locomotive pushed a cut of cars, sometimes 2 or 3 at a time, sometimes a single car, up to the hump's crest at a steady walking pace. At Clearing Yard, that pace was 1.8 miles per hour. Faster, and the timing collapsed. Slower, and throughput fell. The superintendent who spent his career at Clearing once explained it plainly. The success of a hump yard had nothing to do with speed. It had to do with consistency. As each car crested the hump, a tower operator in a glass-walled cab overhead controlled the switch that determined which of the dozens of classification tracks below the car would enter. And the switches were thrown by compressed air, electro-pneumatic systems that could route a car in a fraction of a second. Between the hump and the classification tracks lay the retarders. These were rail brakes built into the track itself. Pairs of steel jaws that gripped the wheels of a passing car and slowed it to precisely the right speed. A loaded boxcar behaved differently from an empty one. A car rolling into a full track needed less speed than one entering an empty track. The retarder operator calculated all of it in real time. Every car that rolled off that hump was going somewhere. The job of the yard was to make sure it arrived on the right track. Before the retarder towers were fully staffed, and before the pneumatic systems were trusted to slow every car, there were the car riders. A car rider was exactly what the name said. When a freight car crested the hump and rolled free into the classification bowl, a man rode it down. He sat on the running board or the brake wheel housing and worked the handbrake, turning the wheel, feeling the car decelerate, reading the speed by sound and vibration and the closing distance to the cars ahead. At Proviso Yard in December 1942, war production was at its peak. Trains were running around the clock. The yard processed defense materials, steel from Gary, machinery from the factory districts west of the city, crated equipment moving toward East Coast ports. The car riders worked through it in shifts. When a car reached its assigned track, the rider climbed off. A motor car ran back along a service track at the edge of the yard, carrying the riders back to the hump for the next cut. In May 1943, a tower man named R.W. Mayberry was documented at his retarder control panel at Proviso Yard. He operated the pneumatic retarders from the hump tower, watching each car through the glass, reading its speed, throwing switches, and triggering retarders in the correct sequence. He did this for every car that crossed the hump on his shift. Thousands of cars, one shift, one man reading the yard. That was the human layer in a system that moved the freight of a continent. When Proviso Yard opened in 1929, it was the largest hump classification yard in the world. The Chicago and Northwestern Railway had built it in Melrose Park, Illinois, on the rail corridor running west from the city. It processed thousands of cars daily on its web of classification tracks. In a yard like Proviso, the incoming train was everything. It arrived from somewhere, Kansas City, St. Paul, Omaha, carrying cars that had been collected from dozens of local freight stations along the line. Some were loaded, some were empty, heading back toward origin. All were mixed. The yard's job was to unmix them. Each incoming train was pulled into a receiving track. Inspectors walked the length of the train, reading the car cards, small paper tags that identified each car's origin, its contents, and its intended destination. From those cards, the switching list was built. Every car got a track number in the classification bowl. The list went to the tower. The tower told the switches where to send each car. When the war came, Proviso ran continuously. Steel from Gary, Indiana, moved through in boxcars and gondolas. Tank components from the Chicago manufacturing districts. Ammunition from the Army's ordnance depots downstate. Every piece of equipment that the American military needed and that the industrial Midwest produced had to pass through a classification yard before it reached a port. Proviso processed it all, around the clock, through the Illinois winters. The system that peaked during the war years began to erode almost immediately afterward. The interstate highway system, authorized in 1956, placed long-haul trucking in direct competition with carload rail freight for the first time. A truck could pick up at a factory dock and deliver to a receiver's door without a single yard classification. It was slower over long distances. It was less efficient per ton mile. But it was direct, and directness had a price that shippers were willing to pay. Intermodal containers arrived at the same time. By the 1960s, shipping companies were moving sealed containers on flat cars. Trailers lifted directly from a truck chassis onto rail. The container did not need to be opened, sorted, or reclassified. It traveled from origin to destination in the same box. The classification yard was bypassed entirely. The loose car freight that had sustained Proviso and clearing, the boxcars of mixed goods assembled at local freight stations and sorted in the classification bowl, declined steadily through the 1970s. Proviso, which had once processed thousands of cars a day, saw volumes fall to fewer than 2,000 by the time Union Pacific shut down its hump in the era of precision-scheduled railroading. Clearing Yard held on. Owned collectively by 6 Class I railroads that still needed an interchange facility in Chicago, and it continued classifying thousands of cars a day. But the geography of American freight had shifted. The era that had made Chicago's hump yards the center of the continent's supply chain was over. What the Chicago classification yards represented was not merely a technical achievement. It was a particular way of organizing the movement of goods. Methodical, labor-intensive, geographically fixed, built on the knowledge of operators who understood the behavior of individual cars in specific weather conditions at specific track grades. That knowledge did not transfer to a manual. It lived in the tower man, who knew when to ease off the retarder pressure in icy December conditions. In the car rider who could feel from the brake wheel that the car ahead had not quite cleared the switch. Or in the yardmaster who looked at an 800-car incoming train and built a switching list in his head before the first car had even reached the receiving track. Clearing Yard still operates. The Belt Railway of Chicago still classifies thousands of cars every day, still dispatches 25 trains in and 25 trains out, still processes 40 to 50 miles of train, consists in each 24-hour period. The hump still runs at 1.8 miles per hour. Consistency is still the measure. But Proviso is quiet. The hump that once handled wartime steel and peacetime grain is idle. The tower that R.W. Mayberry worked in 1943 is long gone. What remains is the record of what the system was and what it took to run it. And if this story gave you a clearer picture of what holds these systems together and what it takes when they come under pressure, subscribe to the channel. There are more corridors, more grids, more operations, and more decisions still to document. And if you have a connection to this kind of work, a relative who spent decades in a control room, a parent who worked a rail yard or a generating station, someone who was there when a system like this was tested, tell us in the comments. What did they operate? Where did they work? What do you remember them saying about the job? The most complete record of how these systems were built and run isn't in any report. It's in the people who were actually there.